Hi everyone, welcome to our lesson, day 6 with electric circuit. As you know, we have two questions, one multiple choice and one normal long question. So please try first and then you can come and correct your answers. Question 1, we have this kind of circuit and then what they ask, which voltmeter will have the highest reading when switch S is closed? This is our question. So in parallel combination, what we know, if you have a current here coming this side, they are sharing current. If they are sharing current, of course, they are getting less current, less than this resistor, this less than that resistor. All right. Because of that, V1 has highest reading. We can continue with numbers if you want. We can just see. Let's just try. Let's say we have 5 or 10. Anyway, just let's say 5A or another number you can use. 2.5A. They are sharing current. And then less current, less voltage because they have same resistance. I hope it is clear. It is fine. Let's continue with next question. Next question, let's see what they're asking. Wow, another circuit, long one. Okay, EMF is 12 volts. Internal resistance, we don't know. And then we don't know X. This resistance also, we don't know what power we know for that. Okay, when switch S is open, what is V1? Question 1, 2, 1, 1 is here. So we can say answer is 12 volts because V1 measures voltage for battery. Switch is open or closed, doesn't matter. Finally, V1, just you will get same result. So 12 volts. EMF 12 volts. When switch is open, EMF is 12 volts. Sorry, when switch is closed, V1 will be different because of the internal resistance we lost. Just we have lost also. So we lost. So V1 will be different. But for now, measures exactly same for EMF 12 volts. All right, let's continue with next question. We are looking for V2. When switch is open, there is no current on 6 ohms. Because of that, V2 equals 0. Because we know from Ohm's law, voltage equals current times resistance. Ohm's law very important for this topic. V is equal to I times R, and you are getting 0 times 6 equals 0 volts. This is our answer for 212. Let's continue with next question. Let's see what they're asking now. Define the power. So we are looking for power, but now S is closed and the reading on the voltmeter is 1.2A. Main current is 1.2A and power for X 5,676. So they're asking you what is power. So some definitions important is that Ohm's law, just like Ohm's law, and power, current. Please try to remember, try to memorize all definitions. Power, the rate at which work is done or energy is expended, transfer, or transfer, you can say. Please try to memorize all. Now let's see what they ask. They're asking you resistance of resistor X. So we are looking for resistance for X. How many ohms? How can we calculate? We know power. If you know power, it is easy because power formula we know. Power formula P is equal to I times V. Power equals I times V, PIV. So for V, if you write from Ohm's law, for V, if you write I times R, so I times I, you are getting I square and then R. So we know power already, we know current already, so we can calculate resistance for X. So we are getting 4 ohms. That's it. Question 2.3. Another option we have from PIV, you can calculate voltage first. When you get voltage, you can use Ohm's law and calculate resistance for X, or you can use this formula to get R. How we are getting this P equals V square over R. So to get I square times R, we wrote I times R for V in first option. But now you are writing here, let's show V times, for current, you are writing V over R from Ohm's law. And then V times V, you are getting V square. So you can use this formula to get resistance. This is our another option. So you can use any option, which one is easy for you, of course. And next question, calculate total external resistance of the circuit. So we know already X is 4 ohms, and we know this too. First of all, we can add 2.4 and 6. We are adding these two, and then 8.4. 8.4 parallel to 6 ohms, and we are calculating parallel combination plus X, and then you are getting external resistance. Okay, so first of all, R2, they said 1 over R parallel equals 1 over R1 plus 1 over R2. This is our formula for parallel combination. 8.4, we are getting directed by adding 2.4 and 6. And you are calculating for parallel combination is 3.5 plus X. You are adding resistance X. It was 4. We calculate already. And then answer is 7.5 ohms. External resistance, 7.5 ohms we can get. And another option, also coming from 1 over R1, 1 over R2, you can write like this also. It's your another option. Next question, calculate the reading on voltmeter 2. We are looking for V2. If you need V2, of course, you need current for 6 ohms. Current for 6 ohms, we are going to calculate. So marking criteria, first of all, when you write formula or Ohm's law formula, 1 mark. And substitution to calculate V parallel, another mark. Substitution to calculate current for 6 ohms, another mark. And substitution to calculate V2 by using Ohm's law, VIR, or another formula is fine. You are getting another mark. Final answer with correct units, another mark. It is marking criteria. Now let's see our solution. First of all, parallel combination, you are calculating V parallel is equal to I times R, because parallel resistance, we calculate already 1 over 6, 1 over 8 over 4. Do you remember? Just we done that. So you're getting parallel combination. When you get parallel combination resistance, divide by 8.4. Divide by 8.4, you are getting current for this side. Current for this side. This current, as you know, what current you have is going to carry on here with same current. And current will not use this way. It means you're getting current for 6 ohms. All right. So why divide by 8.4? Because these two, they are sharing voltage. Because of that, we should just use 8.4, not just 6. All right. So 1.4 times 3.5, V parallel we got. V parallel, we can draw 1 voltmeter here for V parallel. So voltage for this one, for this 6 ohms, and then for 8 points, because this like this, or drawing all just together in one line, also same thing. So you are getting current. Now you have current is equal to 0.5 A. If you know current, if you know resistance, easy to get voltage. I hope you get our steps. First of all, parallel combination, you are calculating voltage by using R parallel and main current, and you are getting V parallel. When you get V parallel, divide by resistance for this branch, so you are getting resistance, and then you are getting current. When you get current times by resistance, you are getting your V2. Step by step, you should try, of course. If you don't get it, please try to write your solution. I hope after that you are gonna get it. This one is just with highest level question. Okay, we can carry on with next question. Let's see what else they are asking. What is our next question? Okay, now they are telling you, okay, a length of wire, all right, with no resistance, is used to connect point P and Q. Okay, you are taking a conducting wire and then connecting P and Q. That's our question. What's gonna happen to your, what's question now? How will the reading on voltmeter V1 be affected? And choose from increase, decrease, or no effect. Explain your answer. So that's our question. So let's try to show. We are drawing, just we are taking a conducting wire between P and Q. They're just using a conducting wire from P to Q. So if you do that, what's going to happen? Your voltage on V1, which one asked V1? Yes, V1 how affected? That's our question. Increase, decrease, or which one they are asking? Yes, V1 decreases. Why? Because total resistance decreases, current increases. We know already if resistance decreases, current will increase. And then internal voltage, we lost increases. We lost increases. Why? Because we lost, what was the we lost? I times R. If current increase, we lost also increase. And then external voltage decrease, another thing, just you can explain, and then you are getting your 4 marks for this question. Okay, because you remove some resistance. If you connect from P to Q, just some resistance getting off, and then total resistance decreases, and then affecting all your voltage. Total resistance decreases, and then your voltage also decreases. V1. This is our question 2 we have done for today. So let's see next lesson what we are going to learn. We are going to carry on with you.